Hello. Welcome back to this beautiful Friday and the episode number 15. If I'm correct, of course, as usual. Too much junk? Yeah, number 15. Today we have something different to do. It won't be Chordie for a while, at least, because I was browsing Reddit and I found this post with this very cool keyboard. And one thing that caught my attention is this tiny fella over here. So I was very curious what it is. Oh, guten Tag, Rudo Brody. Guten Tag. Wie geht's heute? If that's correct, of course. Good to have you on the stream. Yeah, and a big shout out to new follower on Twitch, Inked Black, just followed yesterday. Thank you very much. They're good. Yeah, that's great. That's great. Okay, so going back to the topic from Reddit. So as I was saying, I found this post. And this tiny encoder, it turned out someone made an open source design, which looks like this, and it's absolutely sick. Even it seems like there is even a switch over here. It would seem so. Let's go back. Okay, so yeah, so the whole thing is very cool. And this reminds me that actually at some point in the past, I was also considering mouse encoders, which is what you can see over here. This is a mouse encoder, and these are being used for most of the mice on the market for scrolling. So back then, when I was exploring this topic, I didn't really have a printer on my hand. So I bought some wheels from AliExpress, and the whole experience wasn't great. It was very difficult for me to mount them in a good way. At some point I was considering using two encoders and just attaching the wheel to both of them, but the issue here was that the shaft from the wheel is a bit different on the other side, because in computer mice, the way it's installed is encoders on the one side, and on the other side is just support to hold the wheel, sometimes in a bearing, usually in a bearing. So the other part of the shaft is a different shape, different size, so you can't really fit it inside the same, you can't fit it inside another encoder. So that was an issue, and I didn't have a printer back then. So I dropped the topic, and over time those encoders were just collecting dust, so I threw them away, which turned out to be a huge mistake. And I was trying to find them today, and of course then I realized that most of them are gone for a very long time already. So I had to order new ones, because I can't really let this one slide. I really would like to check what are the possibilities with those encoders. I already have few ideas how to mount them. I was thinking maybe using them in a horizontal position, because if I am not mistaken, these are very soft, so the motion for scrolling doesn't really require this much force as for the ones that we've been exploring before on the stream. So I'm hoping that maybe we will be able to make a mount that will be horizontal, and that will be very cool, because then I can have a really, really low profile. They are very, very thin, few millimeters only thin. So that would be great, especially when it comes to the volume encoder. The only issue might be that there will be no switch, but maybe we can figure out something. That this is something to explore later, but today, since I am waiting on the encoders to arrive, which might take a week, maybe more, so I decided to do something else. And this something else is this. This is one of my prototypes, yet again, unfinished. This is also something that we'll be working on most probably after Chordie. And this is actually a PCB for the keyboard I've been using before on the stream. Which looks like this. Maybe front view will be better. Yeah, so this is actually, I mean, this is actually an earlier version. The PCB is a little bit different, but more or less it's the same design, almost the same wiring. This one has doesn't have infrared over here, and this one does. So we will be building that today. But there is one thing I want to do before we start assembling anything today, and this is we have to figure out a way how to enable adjustments for the infrared sensor, because my initial design was that I have just a resistor over here, and as it turned out, infrared can penetrate PLA depending on the color of the PLA. I think through the white it goes like no problem, and if the color is darker, like black, yes, today will be a little bit of manual, but first we have to dive for a very short while, hopefully, into CAD. Yeah, so going back, what I would like to do, I would like to somehow attach a very tiny potentiometer. It looks like this. So the problem is that it wasn't meant to be there, and the only thing that is included in the build is a spot for a tiny resistor 0805, which should be here. So the problem with this resistor is that initial value I set for 680 ohm, and the problem is that it doesn't really work sometimes with this value. It depends how well the diode sits in the socket, what is the color of the PLA. I also use a shielding for the diode, but it's still a bit finicky, and I have to try different resistors, like 150, 350. I bought these. These are resistor samples or resistor kits. Very useful if you're ever building anything, if it's surface mount or even through hole. You can buy kits like this for the resistors, for the capacitors. This is super useful in cases like this when you have a fixed value but it doesn't work, and you know that all you have to do is to change this value to something else. Then this comes super handy, and it's damn cheap, and usually comes, I don't know how many of them there are. It looks like maybe 20, 50. It's quite a lot of these in quite a lot of values. I don't know if you can see. These are all the values that are here. There could be like maybe 40 different. Oh yeah, this is better. Yeah, so we have 80. I would assume it's 80 different values, 80 different, and 25 pieces each. So this is very useful. This one doesn't have a sticker like that. It has only like this one. Yeah, so this is a bit different. This is I think it's only 33 different resistors, but yeah, this is super useful. So I've been swapping these to check to finally settle on a value that will make the infrared work. But I was thinking that what I can do will be just solder small resistor over here. I think 68 ohm was like the minimum to not burn the diode. So we can attach it here, and then to this one we can attach the potentiometer like this, solder it in, or maybe like this. I am not quite sure yet how it's gonna look like. And then I will just route a tiny wire to here, to the anode. And this should do the trick, hopefully. So the problem is that we have to somehow make space for it on the bottom plate. So the bottom plate looks like this. This is actually the PCB that I just showed you. It has a little bit more holes because initially I designed it to have underglow, and to have also underglow as well as RGB switches. But then I changed my mind because it was still early prototype, so I wanted to cut on the amount of work that I would need to do just to be able to check if the keyboard is correct shape, which it turned out it's not. That's why we have to redo it. So actually I was kind of lucky that I skipped on the RGB, because that would be wasted time routing all of these diodes. So that was good. What is not good is that for this PCB, for this project, if we take a look at the bottom plate, maybe like this. So this is our PCB. So if I remove it, I left cutouts like this. Let me hide this as well, because yeah, so there are different cutouts under the keys, because the way it is assembled, I will show you later when we will be building it, maybe in next stream. The switches are connected in a very odd way for a keyboard, because they are settled like on top of the keyboard. The keyboard is concave. This like a bit like a dactyl. This dactyl inspired. It's I call it dactylized 3I2C, because the layout is from 3I2C, my other keyboard, and the shape is from dactyl actually. So that's where the name comes from. DBD stands for dactyl but different. But later on, when we'll be working on 3I2C, I will just put this keyboard, I will put this shape inside 3I2C. That will be one of the shells for the 3I2C, because the wiring and the layout will be the same. So there's no point making two separate keyboards when technically everything will be the same except for the shape. So going back to our problem at hand, is that this encoder will be somewhere over here. And if we look at it, if I can bring back the PCB, I can hide the bottom and we can take a look from the back. And now all the cutouts should be over here. Yeah, so as you can see, the cutout is oh, it's gonna be difficult for me to talk and show at the same time. So the cutout goes all the way behind this key and up. So we do have some space here, but the encoder, it won't really fit underneath because the bottom plate is thinner than the bottom plate. So I was thinking either leaving like a huge gap, like a huge hole, and leave everything exposed, or maybe if we are lucky, we can solder everything and then try to match the bottom plate. We can make it a little bit thicker. I do have the resistor already modeled, so I can just import it from another project, and we can set up the bottom plate for this. And if we are lucky, if we manage to align it correctly and print, it might happen that will fit exactly how I want it to, which is I want this white thing to stick out from the bottom, because then I can adjust. I can use a screwdriver and I can adjust it. I think this is 10K. Yeah, it's 10 to the power of 2. So it's no, it's 1K. Sorry, it's 1K. Yeah, I do have this designed for Chordie. Let me grab I think I still have the bottom plate, so I can quickly show you what I mean by that. Let me just grab it. Okay, so seems like I don't have it. I'm a compulsive item disposal guy, like a reversed hoarder. I throw away everything, even stuff that I need. So yeah, I don't have it. But fear not, I can show you, at least on the CAD, how it's supposed to look like. Let's hop back to Chordie. And we have it somewhere over here. Yeah, so this is the cutout for the okay, so this is a bit of a mock-up of this resistor. It's 60 RM063. Yeah, so these are those little fellas. So as you can see, they have legs that stick out on the side, like this. I already bent the legs on this one a little. And there should be one more. I have somewhere over here, yeah. So this is another model, and the legs are sticking down like this. So this would be good if I want to mount on a PCB like this. Most probably I would have to clip the pins. So I think I will use these in the future for the PCB version, if we'll be making one. Yeah, but for today I will be using these ones. So I have a cutout already done over here. So this is where it goes in. I wonder if I have it modeled anywhere. Like exactly in this position. I think I had it somewhere. Oh yeah, there is. I have it somewhere over here. Okay, so that's the cutter version. So let me hide everything else. Yeah, so it looks like this. And if I bring back the bottom plate, actually no, I need a base. Yeah. So this is the cutter to cut out the shape from any other body. So I guess I'm gonna borrow this one and move it over here. Let's make a, let's give it like a new name, new component. Let's call it, oh, it should be RM, what was the name? 060, 63. Okay, so let's make it 063. And this is the right part. Okay, so we have it over here now. Of course, it had to drop on the floor. So apparently this is the side with the legs. And I wonder why there are no legs over here. Let's take a look at the ones that I have modeled so far. Is it the same size? So this is 6.4, 6.4, 7.3, 7.8. Okay, why is it so long over here? And it's not that long over here. Okay, I think I will borrow this one instead. What is the distance from here to here? 2.1. Okay, so I will just move this. Makes me wonder what is the distance over here. Okay, looks like there is a small gap. So from here to here, it's okay, 0.1. All right. And what is the radius? 3 points, so it's gonna 6.4. So if I make it 6.4 like this, and now I would like to move it. Okay, let's make a line like this, and I will just make a quick construction line. And now if I move it and I anchor over here, and I would like to be, take the ruler 0.1 from here. All right, so that should do it. Oh, this scrolling is killing me. Okay, so this one was 2.1. All right. Okay, so let's get rid of this one. And this one I will just bind everything together. It will be easier if I have one body like this. Okay, let's take a look at the bottom plate. That looks like this. Okay, I can hide PCB for a second. Okay, so how do we want it? So we have to align it with the PCB level. So it's gonna be like this because PCB ends over here. Let's take a look if I'm correct at this point. Yeah, so we are sitting on the PCB. And now, yeah, so, oh, it's actually it's surprisingly high. Okay, I forgot that the PCB kind of sits inside. So there is an edge over here, and I think it's 1.6. Yeah, so there is an edge around the bottom plate, and this is where the PCB is kind of hiding. I think I should use this one. Yeah, because this this PCB, I mean, this bottom didn't really work the first time because it's too narrow and the PCB is not cut that precisely, so it doesn't fit. So for the build that we'll be doing, I will just go with the one without the edge. So the PCB will be visible, like on the one that I just showed you. I can go back. So as you can see, the PCB, there's a bottom plate over here, then you have the PCB, and then there's the rest of the keyboard. So yeah, the PCB is not really that well cut, or maybe my design is not that detailed as it should be. Okay, so one quick look. Well, I wasn't expecting it to be this thick, actually. Let's take a look. Let's take a look with the calipers, how really tall it is. So it's 4.9. Okay, that's kind of a lot. And is it really the same height over here? Oh, this is 7.3. Something is not... Is this too thick? 5.2 for the base only of the encoder. So I think I got it a little bit wrong. Yeah. Looks like just the base is 2.3. Let's go back and let's check this little fella. Okay, so it's 4.5, and then we have this. So it's still kind of... it doesn't really check out, since the whole piece was 4.8. Okay, 4.9 from the bottom to the top of this part. Okay, so let's take a look. So what's the distance over here? 6.6. Okay, I think I know why, because I have also accommodate for the bottom plate, because this is the cutter actually, so it has to cut through the keyboard plate and as well as through the bottom, like here. So the bottom, let's take a look. If I bring back the bottom, yeah, so it cuts through the bottom as well, a little. Okay. So let's make it 4.9. From here to here, it's 4.9. Okay, so it doesn't look that bad anymore. And if I bring back the PCB, okay, let's move it back. Let's just anchor over here on this wall, and let's move it up to here. Okay, now if I bring back the bottom plate, okay, so it doesn't look that bad. Yeah, so that's what I was expecting. So I was thinking maybe we can make the bottom a little bit thicker. Now I think it's 2.4. Yeah, it's 2.4. And from here to here, we have 0.4. So we have to make it, if you make it 2.8, it's gonna be even with the encoder. So maybe let's make it 3.2. So that will give us 2 layers to cover the encoder as well. Let me just quickly copy and paste. And I will call this one thick. So I can move it. I wonder if I make it like this, and do I have to make it like minus 0.8? Okay, it worked. It worked okay. Okay, so now there is a question how to really align this whole thing. And I think what I can do, maybe I will try to export the component placement from the EasyEDA, because this one was made in EasyEDA. I am planning to switch to KiCad, but that's gonna be in the future. Just like it's just after I start using Git. So for now we have to rely on EasyEDA because all my projects are there. I don't have it import from what I can see, because sometimes I will import all the component placements from the EasyEDA back to my CAD project if I want to like check some things, like if I have to accommodate the bottom plate for some taller components or something like that. But I think this for this one I didn't really have this. They didn't really have such need. Yeah, and all I only did the cutouts for the keys. So that wasn't really import from EasyEDA. That was just, yeah, just making enough spacing to accommodate the wires that are connecting the keys back to the PCB. Okay, so let's jump to EasyEDA. So this is the project. Actually, if you are a beginner in building keyboards, I think EasyEDA is a really good tool. Actually, it's a great tool. It's very easy to use. You have all the components that you need. The library is huge. On top of that, most of the elements that are here, you can use the assembly service at GLC PCB. So basically, you can just create your own PCB, you can put all the components, you can route them, and then you can send everything to GLC PCB, because I think this is one vendor. And you can, with one click, you can jump from EasyEDA to GLC PCB, and the PCB will be already loaded and all the components. And you can order SMT assembly if you're doing a surface mount. So in one click, you have your PCB ready in just like maybe 1-2 weeks. So this is very nice. You don't really have to worry much about creating all the footprints. Although if you have something specific, you can create your own footprints. But on top of that, there is a huge user library, because every footprint that you create, I think it's created as public. So every other user can see your footprints and they can use them as well. I think they can also clone them and just tweak them. So in case you remove yours, they will have a copy. So in most of the cases, you won't be even needing to create your own footprints. You can just use whatever there is, either from the standard library, or you can just use whatever other users created. So this is really great. And it's very easy to use, very easy to route. It works okay. I never had any issues with it. And there's even like an auto router, so you don't have to do everything, every route manually. You can just try to route it automatically. Sometimes it works, sometimes it doesn't. If the keyboard is more complicated, it will have some issues. Yeah, but for smaller projects, if you have a tiny macro pad or something like that that has maybe like 8 keys and there's a lot of space, that is great. You can just, with one click, you can have everything done. You don't have to really worry about anything. Yeah, but with bigger projects, it has issues and you have to do it manually. I think I even have one project where I use the router and it's very messy, and then the other one I had to do it myself because the router couldn't digest it, and I was really rushing. So the one that the router did, I ordered anyway, and it was kind of okay. Let's see. Oh no, this is by hand. Okay, this one is also done by me, and this one was probably as well. Yeah, this one definitely is done by me. Okay, so I have it somewhere, but let's not waste time. Okay, so going back, so on the table I have the right side currently. So this is this one. And we are looking at this piece. So if we jump back to CAD and I remove the bottom, so we are somewhere in this region. So back to CAD, back to the EasyEDA, and I think I can export DXF. Okay, I can try that. Okay, let's do it into downloads folder. Okay, new component over here. Let's call it Easy EDA, and this is the right part over here. Okay, still have caps locks on. Okay, so, and now if I hope I can import like that. And here comes one of the free version limitations. If you're a non-paying user, you can't export DXF and you can't import DXF. You can't import STL. Actually, you can't import anything. And the only thing you can export is PDF and STL. You can't export step, you can't export IGES. Yeah, so looks like DSM, which is Design Spark Mechanical, which is the CAD that I am showing you right now. Over time, they really cut down on the features that are available to the free users. When I was starting a couple years back, I was still able to export DXF, and I think I could even import DXF. I wasn't able to export step and so on, but that never really bothered me much. Yeah, and now in 2025, when you are a non-paying user, so only thing you can do, you can export STL, which is fine for most of the cases, but when you're doing electronics like this might be a problem. Because when you want to place the elements on the PCB, so you create the PCB in CAD like I did, and I have all the cutouts that I need. So you have to import this into the CAD program. So when you're not able to export DXF, you can't really do that, which kind of sucks actually. They also offer their own version of PCB software, but I have never used that actually, so I can't really say much about it. Yeah, but anyway, where were we? We were supposed to import this thing. Okay, so we want to import CAD, and it went into downloads. Don't know which version, let's leave it at default. Oh, this is gonna be save. I don't want to save. I would like to import. Okay, maybe over here. That is interesting. How do I import? Okay, this is export to step file. So this is import PC. Oh, this is add file. Okay. I use it so often that I even forgot where the icon is. So yeah, if you're not paying user, you might still get away with that. Don't have to worry that much. Okay, all files, and let's check this one. Okay, what does it mean? Cyclic dependency. Dependency on what, actually? Okay, let's do it the other way. Let's just open the file like this. Okay, and can I copy that? Okay, we can close Chordie, and we don't want to change anything over here. I think we don't want to change anything. Okay, let's paste. Okay, so I think it's flipped. So let's rotate 180. Okay, I wonder if I can move it. Can I anchor on this? Okay, I can anchor on the mounting screw over here. So if I move it all the way to here, would it work? Okay, wrong hole. That was the wrong hole. Okay, one more time. And now this time I missed. Getting old. Okay, one more try. Third time a charm. Okay, finally. It looks like so far the streams are working. Okay, so we have a nice view over here. Okay, so looking at this. So we are over here somewhere. So I would like this fella to be somewhere over here. Like so. So then the first resistor will come here, and then we'll attach this fella. So I think this is the footprint for the resistor that I was just showing you. Yeah, it looks like it. So let's do a quick check, because the element size is 0805. Let's take a look. Let's take a look over here. So we have a resistor like this. Okay, that's the one, 680. Let's take a look at the data sheet. I don't know why it opened in Easy EDA. Oh, that's fine. Okay, so here we are. So the size is 0805. And these are the sizes. So we have this one. So length is 2 millimeters by 125. Okay, so I will jump back to the CAD and I will make a resistor over here. So it's 1.5 by 2. Is that correct? Length, width, height. No, so it's gonna be like this. 2 by 1.5. Nope. Like this. And it's 0. What's the height? 55. Okay, it's already on the PCB. I forgot that I did it like that. Okay, so now I will try to align to the pad. Okay, so this is more or less. So we will have it over here. So this is where the resistor will be. And then we can solder in the potentiometer. One thing that I'm not quite sure about is which leg is which on this thing. I think if I want to connect, I have to use one of these and the center one, because if I connect this leg and this leg, I think that's the maximum capacity. That's going to be like 1K. And I think the value, I mean the leg that has the variable value, I think it's the the middle one. We can either check with the datasheet or I have a multimeter somewhere. I always get those things wrong. Okay, one more look. It doesn't quite look like. I think everything is mirrored. One more look at the PCB. Okay, that's the different revision. That's the one. Oh yeah, correct. Okay, so that's the one. I left the EZDA on the previous project. Yeah, so I would like to have it somewhere over here. And from what I see, we might end up inside the key somewhere. Yeah, but we don't have this cutout. We only have these two. So, okay. So going back to our CAD program, let's rotate this one. Okay, and it would be wise now to check. Okay, we are, okay, that's not the one. That was RM035. Capacitor, no, so that's the wrong name. Okay, so the name is okay. Maybe they don't have this part anymore. Okay, let's ask Google 035. Okay, potentiometer. Okay, that's odd. Yeah, sure. It does look good though. Okay, let's check. Maybe I am putting the wrong name for it. Potentiometers, okay. Well, how am I gonna find it here? If they don't have it at all, that will be interesting. Maybe we can ask AliExpress. Oh, that is odd. At 063. Yeah, okay. 063. 3 or 5. Okay, we need 3. Okay, now it found. It's over here. Yep, that is the correct one. No, I don't know why it's why is it okay, because I'm browsing from this. Okay, it doesn't say which is leg is which. But maybe we can find it on. Maybe we can find it in the library. Yeah, so it looks like the middle leg is the variable one. Well, we can still check it out. You can grab the potentiometer, multimeter. Just to be double sure. So I think the legs that are on the sides, yeah, that's 1K, and leg from the side, and the middle one, that should be, okay, it's 518 now. Okay. So the middle leg is the one that is variable. So let's align it with the resistor like this. To the midpoint and over here. Okay, so it doesn't really. Okay, so I think I will use this leg. Like this, and then this one will connect to here, and then it goes to the diode, which is over here. That's a route over here. Okay, so we have it more or less like this. So the question now if I show my bottom plate, so we have to make a cutout for the encoder. So this is 6.4. Let's make it bigger, because definitely there will be a little bit more space used by the tin, so it won't be that precise. So let's leave a little bit of like a wiggle room. So maybe if I make it, let's say 7, that's not much, maybe 8. Okay, let's make it 9. Let's make the opening 9 millimeters in diameter. Okay, I can hide this, and I can hide... Yeah, so hopefully there will be enough space. I will have enough space left and right and up and down like this to align everything. But we can check that. It's no problem. Before I start soldering, I can just cut it with a plane like so. Let me just move it a little bit, like maybe we can make it, let's say I would like to be from here. That was 9. So 4.5, let's make it maybe 8. Okay, that will do. So let's cut it into 2 pieces. So now I can hide the other one, and I can hide this. Okay, it looks about right. We will be still able to attach it. We have few holes left, and it's a tiny print. So most likely before I even touch the soldering iron, it should be done. Hopefully, unless Bamboo decides to update something, and that will be it. Or maybe it won't connect to the network anymore like last time. But okay, I don't want to be like negative here about it. Let's hope everything works. So quick STL. How to call it? The most difficult task. How to call it? Let's call it RM bot. So that will be it. Okay, and what I want is Bamboo Studio. And today we are working on Chordie. Oh, haven't I said something? No, I don't want to install. Go away. Yeah, any experience with that, Rudo Brody? Like, you want to do something, then an update pops up, and then you're done. Of course, yeah, everybody. I mean, everyone. We've all been there. Alrighty, so let's print this bad boy. Do we have a view on the printer today? Yes, it works. Incredible. This one is also very picky. Sometimes it works, sometimes it doesn't. But yeah, we have a good view on the printer today. Okay, let's go to our workbench and let's cut to the meat. We're gonna make 2 incredible solder joints. But before I even start, I think I should clean this PCB because it has my greasy hands all around it. So some isopropyl alcohol. So we have 3 followers now, 5 more to go, and we can start our mini side project. Multimedia controller, mini media controller. Okay, let me quickly check on the printer. Okay, the printer is good to go. I also have a new tool on the channel, which is this. Kind of not sure if it's gonna be handy or not. Let's give it a try. Kind of feels too high, in my opinion. Not sure if I like it so far. I think I have to look for a different one, the one that is like flat and you can just put the PCB flat. Well, at least it won't be moving. Okay, 350. I thought I forgot to switch it back from 450 when we were disassembling desoldering the mouse sensor last time. But yeah. Okay, that is a beautiful solder joint. Okay, so what I want is a resistor right now. These are good, but finding one that you need is not good. There's so many of them. It's gonna take a while before I dig through all the... Okay, 62. That was fast. I have 82 as well. Maybe I should go a little bit higher. Because for the 62 ohm, if I rotate the potentiometer all the way down, so that would be only 62. So I think it will be catching for like a half a meter away. We have 20. Oh, okay, I guess I will just stick to the 62. I hope it won't burn the diode. Besides, once it's fully set up, definitely it won't be running on 68. It will be 62 plus something definitely. from the potentiometer. Sorry for all the noises. Okay, I had to mute it because the bug would be making so much noise. Most probably it's not pleasant on the stream to listen to this kind of stuff. Okay, so we have 62 over here. Looks like 62. I'm surprised that I haven't used any. Okay, so we have it over here. It's so tiny. I wonder if it's gonna focus. Nope. It says 620. 620 actually. So this is 62. Okay. I think it's gonna be very difficult to connect the potentiometer with the resistor. So this is how we're planning on doing this. I hope this is enough to bind it together. Okay, it holds. I'm surprised, actually. Yeah, it looks pretty okay. So now we have to wait for the part to finish printing, because at this point I don't really know. Oh, it's finishing. Technically it's done. So quick question, is it gonna fit or not? What do you think? Yes or no? Yeah or 9? Yes, okay. We're gonna find out soon. Let me pick it up from the... Okay, here I am. Here is the part. Okay. It's almost okay. It definitely, it would fit. Or maybe not. Yeah, because I forgot to include the legs in the cutout, as usual. Like, how do I even overlook such things? And I did have a full model, and still... Where is the encoder? Yeah, so I forgot about the legs. Okay, I think I can do like a slot, if I can remember how to make one. I have to click in the center. Okay, like this. And now I think I can move it. Okay, like so. Maybe let's move this one a little bit as well, because it looked like it needs some more space. Let's do... let's not be too greedy. I want it to fit. Although I would want it to be... Oh wait, it shouldn't be like that actually. We should have a nice cutout. Okay, so No, not like this. This is actually wrong. So I'm gonna close this hole. One more thing. So, well, first of all, this is not the. I forgot to thicken the. Oh, how is it? Let's take a look. Oh, okay. Now this explains everything now. So I got everything wrong, as usual. So the encoder, I mean the potentiometer is actually not aligned properly. So it has to go here. Okay, now it sits where it belongs. But how come I did make it thicker? That is kind of, I remember making it bigger. Okay, I moved this one. Making mess as usual. So this is the one that I was supposed to use, and the height is what? 3.6, exactly. So we need to make extra space for it. Let's make maybe 2.4 on each side. Actually, I can connect these. And I still need to offset the bottom. 2.4. I hope that will be enough. Okay, so I have to pull this one all the way to here. So we have a hole that will cover the entire potentiometer. Is it gonna cover? Yeah. Let's be double sure. Yeah, okay, so we are not cutting anywhere. I mean, this is the bottom of the potentiometer, the chassis, and this is the part that we gonna use to set the resistance. And this should be 0.8. Yeah, exactly. Okay, so this is correct. So now we have to make, what was it? Was it 8? I think it was 9. Okay, let's make it 9. Okay, should I make it bigger? Should I make a slot, or should I just print it and hope for the best? Root abroad, if you're still there, what's your take on that? Okay, no response. Okay, so I'm gonna cut this piece. Okay, this time around it should be correct. Okay, so back to bamboo. And I'm gonna reload from the disk. But I have to flip it. Yeah, so slice and print. Okay, so while it's doing its thing, let's take one more look at our PCB now. Maybe front view will be a little bit better. Doesn't seem like they align that well. But I guess we can always move these two parts. I hope it won't desolder on the other end, so we can gently move it around. That is still like a big hole anyway. Okay, so this part is junk. Okay, so I guess we have to wait a while for it to finish. In the meantime, I can start soldering in the diodes. I think I will just do it on the bench like this. No need for the stand. But actually it's kind of okay. Well, what I can do first, I can just put some tin on every one of those pads. Just to remember to put the solder on just one, because if you put on two, that would be difficult to solder the elements later. Oh, I managed to put the solder on two at the same time. I hope they didn't connect. Oh no, it's fine. Yeah, looks good. Oh, well, while I'm here, maybe I should start the fan. Okay, so we have the diodes. Every one of the pads already tinned. But I can also go ahead and put some tin on these large pads, which are meant for the switches later on. So basically this is why I have cutouts in the bottom plate, because then there will be wires sticking out from the other side. So I needed some space, otherwise the bottom plate wouldn't fit. Okay, and our resistor just came out. Came off. Something is not right with this tin. It's been sitting on the desk for quite some time. Seems like we have a problem. This looks better. Oh, I can't get it to stick. So it might happen that my plan wasn't that great after all. We can always skip the resistor. What if I twist it too much? It's gonna burn the diode. Well, it won't stick like that. Not sure what's wrong. Looks like the pads came off. Let's take a new one. Okay, so one side is okay. And now it holds, kind of. Okay, the print just finished. I will just pick it up. Okay, moment of truth is if it's gonna fit or not. Okay, something is off here. Oh yeah, right, because this is right side. Damn it, I have to mirror it. God damn it. Does it even cover the shape? Okay. Has to be more. I have to accommodate for the resistor, it would seem. Okay, back to bamboo. This is how it ends when you have a project that you haven't looked into for quite some time. And then you come back and you forget that like one part was has to be mirrored in order to be able to print. Oh, that's fine. Luckily it doesn't take long. And we can continue with the soldering. But this potentiometer is kind of wobbly. I don't like it like that. I don't think it's gonna hold for long. Yeah, so another thing could be to just use just the encoder. I mean just the potentiometer. I just need to be very careful when adjusting them, not to go too low. Or I wonder if I can use a through hole maybe. There is enough space over here because we will be adjusting this pad right here. So there's enough space over here to have the encoder and the through hole. And I do have such kits for through hole, so that would be okay. And over here is a similar situation. So we could just use through hole and then use the potentiometer. This is an option as well. Anyways, back to the soldering. Okay, let's clean this up. Okay, so this doesn't hold at all. Which is not good. Yeah, it just came off. Well, no surprise that SMT components don't really bind well with the through hole ones. Nope, looks like it's a no-go. It won't stick anyway. Maybe if it was 1206, a bigger one, maybe it would have been better. But 0805, we can't do really much about it. Okay, so what should we do next? Like through hole will be rather large. Let's take a look. I think I have a through hole somewhere. So as you can see, I have plenty of through hole components. Okay, these look smaller. Let's compare. These are 1/8 and these are 1/4. Yeah, so the 1/8 should be okay. I mean, they are smaller, but most probably we will have to account. So what do we have here? Oh my god, there's so many. Some loose in the back. Can't really see anything small. It's either less than 10 or something high with within kilo ohms or even mega ohms, like here. And what is this one? Doesn't say. Okay, 120. This looks like it's the smallest so far. Okay, 82. Okay, that will do. Is there like 60 something around here? 820, 43, that's too low. 36, oh wow. And 30, 20, 100. Is this 100? Difficult to tell. Well, you can measure. 91. This is 56. 47. Oh, 62. Okay, oh, 68. Yeah, we have. So nice. And what is this one? Where did it come from? Nobody knows. Let's take a look. What is the value of this one? $2.1K. So doesn't interest us yet. I'll just drop it in the box. This one is 68. I think I should double check if it's really 68. It's kind of tiny. So that's good. Maybe we'll be able to fit it in. Okay, one more check if it's really 68 ohms. Yep, that is 68. Okay, I'm gonna keep it. I'm gonna keep all of them over here, and this one. And this one we can try solder in. Hope it's gonna hold better than the surface one. I need to cut the leg very short. Oh, that's a nasty one. I'm gonna leave it like that. Okay, looks like it holds. Very nasty. Yeah, but then our plate won't fit, definitely. Okay, so I'm back with the most recent print. So this time I got it correct. Oh well, does it fit? No, it doesn't. Well, it doesn't really need much space. Maybe we can do something about it because there's this blob of tin sticking out. Okay, now it's better. Oh. Still too high. Okay, so it seems the issue is somewhere over here. So maybe I will just cut some more space. All I need is to offset this by 1.2 for the screw. Let's make it 5. Okay, this should be enough. Maybe I will move this. What is the distance from here to here? 2.3. I will make it 1.2 for now. Or maybe even remove this wall completely. And what is the distance from here to here? 2.8. Let's make it 2.4, so there is more wiggle room. And this one minus 1.2. And we can round this corner over here. Okay, I guess I will push the sprint off stream already, because it doesn't make sense to extend the stream to wait just for the print to finish. I think off stream I will try to make it work, try to align it so that there's like enough space even for this non-standard resistor that we have today, because originally it should be surface mount, but surface mount doesn't really have enough surface to connect the potentiometer, which is through hole, to the surface mount resistor. So I have to drop it, and in place I am using 1.8 watt through hole resistor, which is kind of small actually when you look at it, but still it extends a little bit further. So I will just print it off stream, make it work, and on Monday we will continue assembling the PCBs. I am also waiting for the PLA to arrive, because I wanted to have a different color. I wanted to have a gray color. At home I have only black and white, which I don't really want to have a white keyboard, nor I want to have a black. And I have a gray one already, which looks nice, and then we can add like a layer of white that will kind of like split the bottom and the top of the keyboard. That looks very nice, kind of like an imitation of RGB in a way. Yeah, so we will do the rest on Monday. There's still plenty to do. The potentiometers that I ordered for Chordie, most probably they won't arrive by the end of next week. So I guess we have a whole week to finish this build. It's gonna take a while, definitely, because like the PCB is actually the least problematic thing. The keys is where the fun starts. Yeah, and then there was also issue setting up the infrared to make it not to be too sensitive. So if this potentiometer thing works out for us, then that will be one step less in the future to make this keyboard work. Yeah, but for now, for today, thanks for joining. I hope you enjoyed. Please come back on Monday. I promise there will be no more cut anymore. We will be soldering most probably the whole day. Yeah, welcome, Roto Brody. Thanks for joining today and for commenting. It's always good to have you around. Yeah, thanks everyone for watching. Do come back on Monday. Leave a like, leave a comment, or dislike if you didn't like it, what you just saw. Yeah, thanks, and I see you all on Monday. Yeah, have a great weekend ahead. Bye bye.